pressure law or Gay-Lussac law. The statement of the pressure law is the pressure of a fixed mass of a gas at constant volume is proportional to the temperature. So according to the statement of the pressure law, the pressure of the gas is directly proportional to the temperature of the gas. So here the statement of this law is written in the mathematical form. So this mathematical form is saying the temperature of the gas is directly proportional to the pressure of the gas, but this will happen at the constant volume of the gas. So this is the condition of the gas. The volume should be constant. The volume should not change. Now according to this mathematical relationship, if the temperature is more, then the pressure is more. If this temperature is 2 times, so this pressure will be 2 times. Now this is another formula for the pressure law. So here this is P over T and this is equal to constant. So this rule is saying if we take the ratio of the pressure and the temperature, it is constant for one gas, it will never change. Now here on the right hand side there is a PT graph, or it is a pressure law graph, and this graph is between the temperature and the pressure, and this is the shape of the graph, which is rising, which has a positive slope. And the same graph you can see here. So this is a graph between the temperature and the pressure of the gas. So on this axis the temperature is taken in Kelvin, and here on this axis the temperature is taken in Pascal, and this is a pressure law graph, and this is the shape of the graph. It is going upside like this. So what information is coming from this type of graph? Now let us take the 2 points, this point and this point. So here this is 500 Kelvin. So at the 500 Kelvin temperature, the pressure of the gas is coming 10 Pascal. And now take another point, and this is 1000 Kelvin. And at 1000 Kelvin temperature, the pressure of the gas is 20 Pascal. So if you compare this 500 Kelvin and this 1000 Kelvin, so this 1000 Kelvin is more. So this law is saying if temperature more, then the pressure should be more. So here at this we can check from this graph. Here at the 500 Kelvin, the pressure is coming 20 Pascal, and here 1000 Kelvin, the pressure is coming 20 Pascal. So here if you see this temperature 500 and here this is 1000, so this 500 and this 1000, so here the temperature is double. This is 500 Kelvin and this is 1000 Kelvin, so here the temperature is double. Now the pressure here, it is 10 Pascal, and here the pressure is 20 Pascal, so the pressure is also going to double. So it means it is directly proportional. Now here we apply this formula on this graph. So what this formula is saying, we can take 2 points. Okay, so say this is A point here and this is B point here, and at the A point, at the point A, say the value of the temperature is, this is 500 Kelvin, and the pressure value is, this is 10 Pascal. Now what you do, you take the ratio of the P over T. So this pressure is 10 and the temperature is 500, so this is like this, and the ratio is coming, this is 1/50 like this. Now so take the point B. So at the point B, so at this B point, the temperature value is coming, the temperature value is coming, how much it is coming, it is coming 1000 Kelvin. So this is 1000 Kelvin here, and the pressure value is coming 20 Pascal. So this is the pressure value which is coming 20 Pascal. So now what we can do, we can take the ratio of the P over T for the another point, and the P value is 20 Pascal and this is 1000. Now if we solve this one, okay, so this is 0 0 cancel, and if I solve this one, so it will come 1 over 50. 1 over 50. So if you see the ratio of P over T at this A point and the ratio of P over T at this point, so at the point B, so this and this, so both are same, it is not changing. So it means this ratio is constant, it is not changing. Equation of Charles law: Pi over Ti equal to Pf over Tf at constant volume. So this formula will work when the volume of the gas is constant, otherwise this formula will not work. So in this formula, Ti stands for the initial temperature in Kelvin, and Pi stands for initial pressure in Pascal, and Tf stands for final temperature in Kelvin, and Pf stands for final pressure in Pascal. In the previous lectures, I told you about the three gas laws: the Boyle's law, Charles law, and Gay-Lussac law, or the pressure law. So we have discussed about the properties of the law, properties of the Boyle's law, properties of the Charles law, properties of the pressure law, and about the graphs, about the formulas, everything we have discussed in the last lecture. Now on this slide, we are comparing all three laws together in one sheet. So here in the first column, variables allowed to be changed. This is the parameter which is changing in the law. Variables held constant. Here in this column, this is the parameter or the variable of the law which is not changing, which is constant. And here this is the name of the law, and this is the formula for the law, and this is the graph for that particular law. So we can start from the Boyle's law. So for the Boyle's law, which variables are allowed to change? So in the Boyle's law, the pressure and the volume, they are changing. The volume is inversely proportional to the pressure. So here they have the inverse relation between the pressure and the volume. And which parameter is constant in the Boyle's law? The temperature is a constant variable or the constant parameter in the Boyle's law. And the formula for the Boyle's law is the Pi multiplied by Vi equal to Pf multiplied by Vf. And there is a standard graph between the pressure and the volume. This is also known as PV graph, or it is also known as the Boyle's law graph. And this is the shape of the graph like this. When the volume is increasing, then the pressure is decreasing like this. So this is a decreasing graph. If one parameter is increasing, so the other parameter will decrease like this. So this information is about the Boyle's law. Now we will move to the Charles law. So for the Charles law, variables allowed to change. Which variables are changing? So in the Charles law, volume and temperature, they are changing. And the volume and the temperature, they have the direct relation between them. So what is the meaning of the direct relation? If the temperature is more of the gas, then the volume is more of the gas. If temperature is less of the gas, then the volume is less of the gas. So that's why they have the direct relation between the volume and the temperature, and the variable held constant. Which variable is constant in the Charles law? So this pressure of the gas is the constant variable or the constant parameter in the Charles law. And here this is the formula for the Charles law. The Vi over Ti is equal to the Vf over Tf. So this is the formula for the Charles law, and the graph for the Charles law is given here, and this is known as the Charles law graph, or this is also known as the Vt graph. This is the graph between the volume and the temperature here, and this is the rising graph. The graph is going upside like this. So what information is coming from the graph? If the temperature is more, then the volume is more. If one parameter is increasing, then the other parameter is also increasing. So this kind of graph is known as the Vt graph, or this is the Charles law graph. Now we will move to the third law, which is a Gay-Lussac law, or it is also known as the pressure law. So in this pressure law, what variables allowed to change? The pressure and the temperature of the gas is changing, and they have the direct relation between them. The pressure and the temperature, they are directly proportional. So the meaning is, if the temperature is more, then the pressure is more. If the temperature is less, then the pressure is also less. So this is about the Gay-Lussac law or the pressure law. And the variable held constant, which parameter is held constant in the pressure law? This is the volume. The volume is constant in the pressure law. Now the formula for the Gay-Lussac law: the Pi over Ti equal to Pf over Tf, and the graph of the pressure law is given here, and this is known as the PT graph. So this is the pressure on the y-axis and the temperature on the x-axis, and this is the shape of the graph. If you see the shape of the Vt graph and the shape of the PT graph, they are same, but here there is a volume and this is temperature, and for the pressure law, here this is the pressure and this is the temperature, but both the graphs are rising. If one is more, then the other is more. If the temperature is more, then the pressure is more. So if one is increasing, if one parameter is increasing, then the other parameter is also increasing. So what information we are getting from this table? So one thing is very clear about these laws. In this law, there are three parameters are there. The one is the pressure, and the other is volume, and the third one is the temperature. So three parameters are used in these three gas laws, and in each law two parameters are changing and one parameter is constant all the time. So here, like for the Boyle's law, this PV changing and T not changing, and for the Charles law, the volume changing and the temperature changing, but the pressure not changing. And for the Gay-Lussac's law or the pressure law, pressure changing and the temperature is also changing, but the volume is not changing. Thanks for watching.